This is the video for section 8.1 notes, slides 7 and 8. All right, so it still falls under the category of area between curves, but in this section we're talking about the two concepts of one called displacement and the other called total distance. All right, and so we're talking about when we're given a velocity function, right? Or I guess we could be given a position function or something else, but basically, given a velocity function, how do we find the displacement of an object that travels with that velocity? Or how do we find the total distance that a particular object has traveled? So we need to make sure we understand, first of all, the difference between the two. All right, so let's imagine that we have a number line, all right, and we are starting on the origin of the number line, the point 0, right? So now let's say that I start here and I travel 1 unit to the right, then I turn around and I travel 2 units to the left. All right, so now, a couple questions. What is my displacement? My displacement is -1 because that is the relationship, that shows the relationship to my original location, right? I am 1 unit to the left of my original location. All right, now, that would be displacement. All right, but total distance. What is the total distance that I've traveled? Well, I traveled 1 unit to the right and 2 units to the left, so my total distance traveled would be 3. So my displacement here is -1, and my total distance is 3. So how do we figure these out? Well, we find the displacement by taking just the integral from a to b, right? That's like the starting time to the ending time of the velocity function with respect to t, all right? And the total distance traveled is the integral of the absolute value of v. So it doesn't matter which direction you're going, all right? It just matters how far you've traveled. All right, so now let's imagine this in terms of a graph of v. All right, so let's say we have a graph of v of t here, right? So this is v of t, and obviously the x-axis is time. All right, so now let's say I have a graph that looks like this, something like that. All right, it doesn't, I mean, it's a curve of some sort, whatever. It's not necessarily like a sine function or whatever. All right, so now let's say that this area, geometrically speaking, is 4, and this area, geometrically speaking, is 2. All right, now, the displacement would just take the integral, right? So this would be 4, and this would be a -2 because it's below the x-axis. So the displacement here would end up being 4 minus 2 would be 2, meaning what? We started at some location and we traveled 4 units forward and then we traveled 2 units backwards. So meaning our displacement is 2 units to the right or in front of where we started from. Okay? But then the total distance. All right, the total distance traveled, well, it doesn't matter which direction you're going. So we went 4 units forward, and then we went 2 units backwards, so the total distance traveled would be 6. All right, so remember, algebraic area, positive area above the x-axis, negative area below the x-axis, and geometric area is simply how much space is taken up there. So, right, so that's a total of 6. All right, so we have to make sure we understand. Now, okay, how do we actually do this? So this came up in the review for Unit 7, but, okay, how do I actually calculate the integral of the absolute value? Now, when we had, like, the integral from, like, I don't know, 0 to 2 of the absolute value of x minus 1 dx, we were able to calculate that geometrically, right? We drew the graph of the absolute value graph, shifted 1 unit to the right, and we said, okay, we're looking for this area from 0 to 1, and then this area from 0 to 2, right? So we just found the area of 2 triangles, all right? But that's a little bit more challenging when we have a curve, right? So let's say we have the integral from 0 to 2 once again, all right? But now we have the absolute value of something like x squared minus 1. dx. Now, that's a little bit more challenging. All right, so first of all, we need to think about what the graph of x squared minus 1 looks like. All right, so x squared minus 1 is the parabola that has been shifted down 1 unit, right? So it goes down to -1 here, and its x-intercept is +1 and -1, right? So now, what am I interested in? Well, any of this area that is below the x-axis, so let's say this stuff, would actually be flipped above the x-axis to give the absolute value graph. So we would have a graph that looks like this. Here's -1, here's +1. All right, so we have this curve coming up above the x-axis there. Then we have this curve above the x-axis there, and then this part that was below actually gets flipped up above. All right, and so what are we looking for? We're looking for this area and then, well, this area, right? If we're going from 0 to 2. All right, so how do we do this? Well, what we have is this area between 0 and 1 originally was a negative area. So what we're going to do is we're going to integrate the x squared minus 1 function with respect to x from 0 to 1. Okay, now, looking at the picture, we know that that integral, remember, there's no absolute value there, that integral is going to be a negative value. So we're going to put a negative in front to make that area a positive value. All right, then we're going to add to it the integral from 1 to 2, right, which represents this area over here of x squared minus 1 dx, right? So we take the opposite of the negative area and we add the positive area, okay? And we combine those two and we are going to get, remember, this should only be a positive result. All right, so let's actually calculate this. All right, so I have the negative in front, all right, and then I'm going to integrate x squared minus 1. So x cubed over 3 minus the integral of x is just 1, and then we're going to evaluate that from 0 to 1, and don't forget about the negative in front. All right, and then plus, well, the integral is the same, x cubed over 3 minus x, and evaluate from 1 to 2, right, and then we're going to add those together. All right, so let's do that work. All right, remember, this is actually really simple. We're just plugging in 0, 1, and 1 and 2, right, so this is not a big deal at all. All right, so I've got the negative in front. Now, remember, the negative goes to the entire result here, right? So I've got 1 cubed over 3 minus 1, and then minus 0 cubed over 3 minus 0. Of course, that whole thing is 0. All right, then plus this whole thing, so 2 cubed over 3 minus 2 minus 1 cubed over 3 minus 1. All right, and so now we just have to simplify a little bit. So I'm going to keep the negative on the outside. All right, I've got 1 cubed over 3 is 1/3 minus 1. So subtracting 1 is like subtracting 3/3. So this is negative 2/3, right? And then, of course, minus 0. All right, plus, now this one, 2 cubed over 3, that's 8/3 minus 2, that would be like minus 6/3, so that'd be 2/3, and then minus 1/3, or sorry, 1 cubed over 3, which is 1/3 minus 1, which is minus 3/3, so 1/3 minus 3/3 is negative 2/3, but I'm subtracting it, so it's like adding 2/3. So remember, the first part, we took the opposite of negative 2/3, so this is actually positive 2/3. This result has to be positive, right, because this is above the x-axis, and then plus another 2/3 and another 2/3, right? And so our result is 6/3 or 2, right? So that is the, what would that be once again? Remember, we are calculating the total distance traveled. Okay, now what would the displacement be? Well, the displacement would just be the regular integral. Now, we could take from our work here, the regular integral just wouldn't have a negative in front, so the regular integral would just be 2/3, right? So remember, what does this thing mean? This thing means that we traveled 2/3 of a unit backwards, then we traveled 4/3 of a unit forwards. All right, so that's how we calculate displacement and total distance. All right, and so now on slide number 8. All right, slide number 8. All right, an object is moving along a horizontal number line so that the velocity at any time, t seconds, is v of t equals 2 cosine of 4t feet per second, where t is between 0 and 5 pi over 8. Find the displacement and the total distance traveled by the object for t between 0 and 5 pi over 8. All right, so I have 2 cosine of 4t. All right, so first thing we need to do, well, we need to remember, all right, the displacement, right, is going to be the integral from 0 to 5 pi over 8, right? Those are the limits that were given of the function 2 cosine of 4t dt, right? So we're just going to calculate that normally, right? That's going to be the displacement. But then the total distance, all right, the total distance traveled, that's going to be the integral from 0 to 5 pi over 8 of the absolute value of 2 cosine of 4t dt, right? So obviously they're both going to be a little bit of work, all right, but let's go ahead and let's start with the displacement, right? All right, so in order to integrate, I'm going to need a u substitution. U equals 4t, so du is 4dt. So I would bring the 2 in front, and I have the integral from t equals 0 to t equals 5 pi over 8. And I brought the 2 out, so I have cosine of u, and then remember dt. Well, I would need a 4 with the dt, which means I would need to divide it by 4 on the outside. So I have integral of cosine of u du, all right? And so now I have 1/2 really in front, integral from t equals 0. So what if t is 0? Well, u is 0, right? So I'm going to change the limit. And then if t is 5 pi over 8, I have 4 times 5 pi over 8, so that would be 5 pi over 2, right? If I multiply by 4, then I reduce the 4 and the 8 to get a 2 in the denominator. All right, so now integral of cosine of u du. All right, so what is the integral of cosine? Okay, it is sine of u, right? All right, so I get 1/2 sine of u evaluated from 0 to 5 pi over 2. All right, and so half of the sine of 5 pi over 2 minus half of the sine of 0. All right, so that one's actually not too bad. All right, and so I get sine of 5 pi over 2. All right, so now remember, you got to think about unit circle. One whole time around the unit circle is 4 pi over 2, so another one is 5 pi over 2, so the sine of 5 pi over 2 is 1. So I get 1/2 times 1 minus 1/2 times the sine of 0. The sine of 0 is 0. So my answer is 1/2, right? The displacement is 1/2. What does that mean? Once again, that means the object is half of a unit to the right of where it started. All right, total distance. All right, now this is a little bit more work. Why? Well, because I have to know what parts of this graph are above the x-axis and what parts are below the x-axis. So what does that mean? Okay, yes, I could draw a graph or whatever, but really what I'm going to have to do is I'm going to have to figure out when 2 cosine of 4t is equal to 0, right? I'm going to have to figure out the zeros, and then I'm actually going to have to do a sign analysis to determine when this function is positive and when this function is negative, so I know how to split the integral up. All right, so this is all the way back to chapter 4 and 5 from pre-calc, and then actually we did a lot of this work with sign analysis in unit 4 in calculus during first semester. All right, so I'm going to divide by 2, so I get cosine of 4t is equal to 0. So now, when is cosine equal to 0? Right, so you have to remind yourself, cosine is equal to 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. And so I'm going to say that the angle for t is equal to pi over 2 plus pi n, right, for any integer n. So it's important to remember that you write the general solution, because now you're going to divide by 4. So you're going to say, okay, well, t is pi over 2 divided by 4, which is pi over 8, plus, now I also have to divide this by 4, so pi over 4n, right? So t is, okay, so now pi over 8 plus 0. So pi over 8 is our first solution, and that is between 0 and 5 pi over 8. All right, now I'm going to add pi over 4, which is like adding 2 pi over 8. So 1 pi over 8 plus 2 is 3 pi over 8, which is still between 0 and 5 pi over 8. Add another 2 pi over 8, and I get 5 pi over 8, which is one of my endpoints. All right. So now, what do we have to do? Well, we actually have to do the sign analysis. All right, so sign analysis. I'm starting at 0, and I'm going to 5 pi over 8. All right, and remember, I've got pi over 8 here, and I've got 3 pi over 8. All right, so now, on the side, I have 2 cosine of 4t. All right, so now I have a 0 here, a 0 here, and a 0 here. All right, so let's plug in 0 to start. 2 times cosine of 0. Cosine of 0 is 1, so this is positive. All right, in between pi over 8 and 3 pi over 8. Well, easiest one is 2 pi over 8, or pi over 4. So I get 2 cosine of 4 times pi over 4. Well, the 4 is reduced, and I get 2 times cosine of pi. Cosine of pi is -1, so that means this is negative. All right, between 3 pi over 8 and 5 pi over 8, well, obviously, 4 pi over 8. So 4 pi over 8 is 2 pi over 4, so the 4 is reduced, so I get cosine of 2 pi, which is positive, and so I now know when the object is traveling to the right and when it's traveling to the left. All right, so now what do I want to do? So the total distance traveled, right, we're going to take the regular integral of the positive portions. So I'm going to take the integral from 0 to pi over 8, of 2 cosine of 4t, right? All right. Then I'm going to subtract the negative portion, so the integral from pi over 8 to 3 pi over 8 of 2 cosine of 4t dt, and then I'm going to add the positive part at the end, 3 pi over 8 to 5 pi over 8, the 2 cosine of 4t dt. Now, we've already done the work over here to actually do the integral. So really now all it is just plugging these values in correctly, right? Okay, and appropriately changing the limits, right? So I'm going to bring the 2 outside, right? So they all have the 2 outside, and then the u substitution brings a 1/4 outside. So all of them are going to be 1/2, right? And then remember, we integrated and we got the sine of u, right? And then we're going to evaluate. Minus 1/2 the sine of u, and then we're going to evaluate, plus 1/2 the sine of u. Okay, now, I didn't write the limits. Why? Well, remember, these limits here are t's. So now we need to think about with u substitution. All right, if t is 0, u is also 0, so this is 0. All right, if t is pi over 8, then 4 times pi over 8 is pi over 2. All right, the next one. Okay, pi over 8, we already got that. That's pi over 2. All right, what about the upper one? This is 3 pi over 8. So 3 pi over 8 times 4, right, is going to be 12 pi over 8. Or 3 pi over 2, right? They're both divisible by 4. All right, and then the last one, we already got the bottom one, 3 pi over 2. And the top one, 5 pi over 8 times 4 is going to be 5 pi over 2. So now, once again, we just need to plug in, right? All right, so I've got the first one, 1/2 the sine of pi over 2 minus 1/2 the sine of 0. All right, minus 1/2 the sine of 3 pi over 2 minus 1/2 the sine of pi over 2. And then plus the last one, 1/2 the sine of 5 pi over 2 minus 1/2 the sine of 3 pi over 2. All right, so now we just need to simplify. All right, so half of the sine of pi over 2. Sine of pi over 2 is 1, so this is 1/2. Minus the sine of 0 is 0. Minus, all right, 1/2 the sine of 3 pi over 2. Remember, the sine of 3 pi over 2 is negative 1, so this becomes a negative 1/2. Minus a 1/2 the sine of pi over 2. The sine of pi over 2 is 1, so we're subtracting 1/2, right? So negative 1/2 minus 1/2, right, is negative 1, but remember, we're subtracting it. All right, plus, then I've got 1/2 the sine of 5 pi over 2. Remember, 5 pi over 2 is the same as pi over 2, and so that's a positive 1, minus 1/2 the sine of 3 pi over 2, and remember, the sine of 3 pi over 2 is negative 1, so this becomes a plus. Now, remember, okay, this result in there should be positive, this result in here should be positive, and this result in here should be negative, right, because we knew it's under the x-axis, which is why we're subtracting it. All right, and so what do I have? I have 1/2 plus 1 plus 1. So this is 2.5 or 5 halves. And so there is a lot of stuff that you have to know in order to do this correctly. Unit circle, use substitutions, integrals, sign analysis, all of that. But that is finding the displacement and total distance traveled.